Hit that subscribe button and join the Visitor Bliss community. Let's find the world's most beautiful spots together. India has achieved a major breakthrough in science and energy. The prototype fast breeder reactor, or PFBR, at Kalpakkam in Tamil Nadu has reached what we call criticality, which is, honestly, a key moment in nuclear power. This is more than just a technical milestone. It is a proud leap for India and a turning point for the country's energy future. So, why is this such a big deal? Well, energy needs in India are growing fast. Safe, clean, and reliable sources are crucial. The PFBR is a symbol of India's determination to find its own solutions. It shows the world that India can create and manage complex technology on its own. This historic moment has not come overnight. It is the result of years of hard work by so many Indian scientists, engineers, and companies. The PFBR now stands tall, not just as a machine, but as a beacon of hope for energy security and self-reliance. The world is watching as India steps into an elite group of nations with advanced nuclear abilities. The Kalpakkam PFBR is not just a success story. It is the start of a new chapter in India's journey as a science and energy powerhouse. Criticality is a word often heard in the world of nuclear energy, but what does it mean? Simply put, it is the point where a nuclear reactor starts a controlled chain reaction. This reaction produces heat, which is then used to make electricity. Reaching criticality means the reactor is working just as designed. Not too fast, not too slow. Getting to criticality is no simple task. It is kind of like lighting a fire that must never go out of control. Scientists and engineers have to balance everything perfectly, from the way the fuel is arranged to all the safety systems. When the PFBR at Kalpakkam achieved criticality, it showed that the technology is safe, stable, and ready for the next steps. This moment is historic for India because it is the first time the country has reached criticality with such a complex, home-built fast breeder reactor. It is proof that Indian teams can master the most advanced forms of nuclear science without needing help from abroad. Criticality is just the beginning, but it is the most important milestone in a nuclear reactor's life. It means the PFBR can now move towards making clean electricity for millions, using science born and bred right here in India. The PFBR at Kalpakkam is not an ordinary nuclear reactor. Its design is honestly special and advanced. Most reactors in the world use water as a coolant, but the PFBR uses liquid sodium. This is one of the things that make it unique and efficient. Inside, the PFBR uses a special fuel called MOX, which stands for mixed oxide fuel. This fuel is a blend of plutonium and uranium oxide. Unlike regular reactors, the PFBR is designed to produce more fuel than it burns. That's why it's called a breeder reactor. The use of liquid sodium as a coolant is quite clever. Sodium does not slow down neutrons, so the reactions happen faster. This helps the reactor breed even more fuel from the original material. But working with sodium is tricky. If it touches water or air, it can react violently. That's why safety systems are extremely strong and carefully tested. The PFBR's design is a blend of Indian innovation and global science. Every part, from the metal used in its core to the computers running safety checks, is a result of years of Indian research and development. At the heart of the PFBR lies its MOX fuel. MOX stands for mixed oxide, a combination of plutonium oxide and uranium oxide. Plutonium comes from spent fuel of earlier reactors, while uranium is more common. By mixing them, India can recycle nuclear material that would otherwise go to waste. This smart use of MOX fuel does two important things. First, it helps India make better use of limited uranium resources. Second, it creates new plutonium as the reactor runs. This new plutonium can be used as fuel in the future, making the whole system very efficient. The PFBR uses liquid sodium to cool the reactor instead of the common water. Sodium has unique properties. It can absorb a lot of heat and stays liquid at high temperatures. This allows the reactor to work at higher efficiency. However, sodium is also reactive, so safety is a major focus at every step. Using MOX fuel and sodium coolant puts the PFBR in a special class of reactors worldwide. It is a challenge, but it is also a chance for India to lead in nuclear innovation and sustainable energy. India's nuclear journey is, well, carefully planned in 3 stages. The first stage uses natural uranium in heavy water reactors. These reactors have actually been working for decades, providing valuable electricity and creating plutonium as a byproduct. Now, the second stage, where the PFBR belongs, is all about fast breeder reactors. These reactors use the plutonium made in the first stage, along with uranium, to make more fuel than they consume. The PFBR is, you could say, the bridge between using limited uranium and moving towards even greater self-reliance. The third stage is honestly the most ambitious. It aims to use thorium, a silvery metal found in large amounts in Indian soil. Thorium isn't directly usable as fuel, but with the plutonium from stage 2, India can turn thorium into energy. This could give India clean electricity for centuries. The PFBR is not just a reactor, it is a key part of India's grand plan to use its own resources. It brings India closer to a future where energy is clean, reliable, and truly made in India. With the PFBR's success, India joins a small, elite group of countries with fast breeder technology. Only a few nations, like Russia, France, and China, have built such reactors. These countries lead the world in nuclear science and energy independence. This achievement, honestly, boosts India's strategic strength. It means India can make its own nuclear fuel and recycle it, reducing the need to import expensive uranium. Energy security is now closer than ever. The world has noticed. Leaders and scientists from many countries have congratulated India for this rare feat. India's PFBR also gives hope to other developing countries. It shows that with skill, patience, and teamwork, world-class science can be achieved locally. This new status opens doors for international cooperation, technology sharing, and even future exports of Indian nuclear know-how. The PFBR is a symbol of India's arrival as a global science and technology leader. It inspires pride at home and respect abroad, strengthening India's voice in the world of energy and innovation. The journey to build the PFBR was long and challenging. From the first drawing to the final criticality, it took almost 2 decades. Thousands of Indian scientists, engineers, and technicians worked together, often facing problems never seen before. Many companies, especially small and medium enterprises, played a big part. They made special parts, built new machines, and helped test systems. Every nut, bolt, and computer code was made or carefully checked in India. This teamwork is honestly a proud example of Make in India. The PFBR team had to solve tough problems. Liquid sodium is hard to handle. Making MOX fuel needs exact science. Safety systems had to be perfect. Every step was tested and checked again. Sometimes there were delays, but each one made the reactor safer and stronger. This success belongs to every person who worked on the PFBR. Scientists, engineers, workers, and industry partners. Together, they proved that India can solve the hardest problems and build world-class technology. The PFBR is just the beginning of a new journey for India. Soon it will start making clean electricity for thousands of homes and industries. Because it breathes more fuel than it burns, it leaves less waste behind. This is good for the environment and for future generations. With the PFBR working, India is now closer to using its huge thorium reserves. This will give the nation energy for hundreds of years. There's no need to worry about running out of fuel or buying it from other countries. India can stand on its own feet. The success of the PFBR means more jobs, more research, and more world-class science in India. Young students and scientists can dream bigger. They know that with hard work and teamwork, they too can change the future. For every Indian, the PFBR is a source of pride. It shows what can be done with brains, unity, and vision. The world now sees India as a country that leads, not just follows. The prototype fast breeder reactor at Kalpakkam is more than just a machine. It is a powerful symbol of India's scientific spirit and determination. With its criticality, India has stepped boldly into a new era of nuclear leadership. The PFBR makes India safer and stronger. Clean, reliable energy is now within reach, and the country can use its own resources wisely. The reactor is a bridge to a future powered by thorium, a future that is clean, green, and secure. This achievement was made possible by the hard work of thousands of Indians, from top scientists to factory workers. It is proof that when India sets its mind to something, it can reach the highest heights. India's nuclear leap does not just change its own destiny, it sets an example for the world. The PFBR is the start of something bigger, a future where India leads in science, innovation, and clean energy for all.